Good evening. Welcome to Matlab Masterclass Series Day 2. Firstly, I would like to thank the co-host IIT Mumbai for their cooperation. I would also like to thank for your participation as well as for your time. I thank you once again. Let us go into the session. Yesterday, we got some feedbacks from the chats, to reduce the speed of the lessons. So today, we noted the point, and I try to reduce my pace and to increase the font size of the Matlab. So we have also increased the font size today. So the menu fonts cannot be increased. Maybe the editor window and the command window can be increased. So that we have done. We have increased the font size today. And to wrap up on time, today, we will be completing the session within 45 to 50 minutes of time. So that I can assure you. And volume up. I think we are in this part also. It's will be done today. We have increased the volume. So these feedbacks are noted. So we'll try to keep these points. So day 2, day 1 is we have covered up some getting started with Matlab, and we have gone through the various commands command window. We have gone through what is command window and what is editor window and what is command history and debug and how to write for loops. Those things we have caught up yesterday. So today's session is on image processing using Matlab. In this session, we have reduced to only to 7 points. It's a vast area. So we are giving only the basics today. So how to read and store the image, that will be covered up in the first session. What are the commands which we use to store, read different type of images, and how to view the pixels. That we will be seeing the first session. And second, types of images, and how to read a color image, how to convert to grayscale, and how to convert the grayscale to binary image, and what are the commands involved in it. That we will be going through on the second session. And third is mathematical operations. In this, we will be covering up image addition, image subtraction, and image multiplication. How to increase the intensity by using image addition, and how to do background subtraction by using image subtraction. So those things we will be covering up in this part. In channel separation, we will be taking a color image, and we will be splitting the channels, the red channel, green channel, and the blue channel for color image processing. So this channel separation is used for color image processing. So that we will be covering up in channel separation. And edge detection, we will be going through various edge detection techniques, Sobel edge detection and canny edge detection and pre-width edge detection. How to apply this edge detection techniques on a grayscale image. And noise and filtering, we will be covering up noise like salt and pepper noise and Gaussian noise, and how to apply Wiener filter and median filter for these noises to remove the noise from the image. So that will be covering up noise and filtering. And finally, thresholding and image segmentation. How to threshold the image by using histograms, as well as how to identify threshold on a histogram image, and finally how to segment those images based on thresholding. That we will be covering up today. So I'll try to reduce the speed today. So let us go into Matlab. So how to read and store images, right? So in this example, I have the first line is imread of cameraman.tiff, right? So a equal to imread of cameraman.tiff. In this, we are reading an image to a variable a. So that will convert the image to a pixel, right? So the TIFF is a file format, tagged image file format. There are a lot of different type of file formats out there. BMP is a type of file format. JPG is a type of file format. It's a compressed file format. PNG, portable network graphics, and PGM, portable gray map. So these are all the different type of file format. So Matlab will read any type of file formats. It will read JPG, it will read PNG. Whereas in C, you need a different program for every file formats. Whereas in Matlab, no need to worry about the header structure. You can give imread to read the image to a variable, and imshow of a is used for display the image, and impixel info is used to check the pixel size. You could move the cursor and you could check the pixel, like what is the value of the pixel, that you can check. And imwrite is the command which is used for writing the image to other file formats or in some other names. For example, if you're doing some image processing on an image and you want to store the final image, then you could use this command imwrite. Okay, so medical image cannot be read through imread, so you have to use DICOM read. So DICOM images cannot be read through imread function, so you have to use DICOM read function for that. And so it's a 16-bit imread, like most of the images will come under 8-bit data, whereas medical imaging standards will come under 16-bit data. Okay, so I'm going to open this Matlab and I'm going to show this example first. So this window is called command window. So I'm going to type edit to open the editor window. So I'm going to read an image. This image has been stored in the Matlab default directory. Okay, cameraman.tiff. So you have to read this image. Issue of A is used for display. I'm saving this image. I'm saving this program ex1 example 1. Okay. So once you save the program, hit the run button. So this is the image. Okay. So if you want to view the size of the image, whos of A will give you the size of the image. This image is 256 rows and 256 columns. So these are all the pixel values. If you want to view the pixel values, you have to type impixel info and hit the run button. So if I move the cursor, like you could notice that at bottom of the line you have pixel location as well as intensity. Okay, so once you move this one, like you could check intensity. If you want to read a color image, the image should be on this folder. So I am taking a color image here. So I'm storing inside this folder demo2. So rows.png. Okay, save the program and run the program. So this is the color image, and if you check this one, you could notice 3 pixel values, like for each and every location, like red, 1 pixel will be there, for green 1 pixel will be there, for blue 1 pixel will be there, right? Only the combination of RGB will give you the color. So if you want to check the size in the program, so you could type RCP equal to size of A. This will give you the size. So if you check the value of R, it will give you the rows and it will give you the columns and it will give you the planes. Plane will be 3 for color image. So you could also check it on the workspace. So 387 into 467 into 3. Okay. So if I want to resize this image, B equal to IM resize. Resize of A, comma 256, comma 256 rows and 256 columns. So I'm going to display another plot. So I'm going to use subplot for this. Subplot of 1, 2, 1. And 1, 2, 2. Okay. Show of B. save the program and run the head button. So if you check this window, so this is the resized image, this is the original image, and this is the resized image. If I want to store the resized image, imwrite of b comma test.png will create test.png in the current folder. So if you check here, rose.png, right? So hit the run. So you got test.png in the current folder. So if the file is not here, then you have to include the path name. So I'm repeating one more time. So we are reading an image here by using a command called imread, which will store the pixels in at A. Okay, so you could check the size of the variable in the workspace, and size is a command which is used to calculate the number of rows and number of columns and number of planes. For color image it will be 3. For black and white, if you take black and white here, cameraman dot tiff, the plane will be, number of planes will be 1 for grayscale image. So if you check the value of p equal to 1. For color image it will be 3. For you will be getting 3 matrix, you will be getting single matrix for cameraman dot tiff. So im resize is a command which is used to resize the image and subplot, and imwrite is a command which is used to store the image. If you want to read DICOM images, I'm going to take image from a default folder. So help DICOM read. I'm typing a command called help DICOM read in the command window. So I'm getting a sample here. Okay, copy this program. I'm creating a new file here. Save the program. Paste. Okay, I think it's not copied. Right click, copy, paste. Okay, so if I save the file to ex2 example2, so it's taking some time. Matlab, it's taking some time. It's not seen, so hit the run button. So if you check here, this is a medical image, so it's not clearly visible. So because it's a 16-bit data, so you need to change the command for imshow. Now if you run button, see, this is the image, this is the medical image. So if you check here, a DICOM info will provide you the information about the image, when it is created and what is the size and everything. If you check here, see, you copy info and you put it on the command window. So if you check here, so this is the file name, modify date, file size, format and format version, width and height and bit depth and color type, everything will be here. Okay, so this will give you the information. So this information you have to read in DICOM read. So Y will contains of the matrix which contains the pixels. So it's a 512 into 512 matrix with 16-bit data. So if you type Y here, so pixel values. Okay, usually the pixel value for normal images will be 0 to 255. It's 8-bit. Whereas for this DICOM image it will be around 48, it's a 16-bit pixel data. So the next part is on types of image, like how to convert color image to grayscale and binary form. Okay, I'm going to create a program. I'm going to clear the variables. I'm going to close all the figures which is previously created, CLC for clear screen, and I'm going to read a color image. Read is a command which is used for read the color image. Rows.png. Okay, imshow of A is for display the input image. Okay, and B equal to RGB to gray is to convert the color to grayscale, and imshow of B. Okay, to convert to binary, IM to BW of B, imshow of C. Okay, so in order to view in a single window, I am giving subplot of 1 row and 3 column I am going to have. This is the third image. Copy this one, this as 2. EX3. Okay, so run the program. So this is the rows, this is the color image, and this is the grayscale image, and this is the binary image. Okay, if you want to view the pixel, like IM pixel info, you could place IM pixel info at the bottom. Save the program and run the program again. So you could keep, so if you check here, like you got RGB, right? You go on the bottom line, like here, like pixel info x comma y will give you the location, and pixel value, this will give you the pixel value. RGB stands for like red, green and blue, and this is for grayscale value. Okay, pixel value, and this is binary. Binary will have only zeros and ones information. So this is an example to convert a color to grayscale and grayscale to binary. Okay, I will explain you the code once again. So first I am reading an image. A equal to IM read of rows.png will read an input image, and A contains C matrix which contains the pixel information. Okay, for color it contains 3 planes. So RGB to gray is a command which is used to convert to grayscale. So this will contain only one plane. Okay, subplot is a command which is used to plot in a single window. So this one denotes like it contains of going to have 1 rows and 3 columns. Okay, and this is the index, like first, this is the first image, and for this B we are going to display. So this is a subplot denotes this 2 denotes this is the second image. So IM show of B, and C equal to IM to BW gives the image to binary form, and C will contain a binary value, and we are displaying it in a third image, subplot of 1, 3, 3. So IM shows IM pixel info. Okay, so these are the types of images. So mathematical operations in image. Okay, so I'm going to create a new program, and I'm going to first clear the screen, clear the variables, and close all the figures which was opened in the previous program, and I'm going to read an image. I'm going to read an image, cameraman.tiff. Tiff is a tagged image file format. Okay, cameraman.tiff, and B equal to IM add is the image addition. Okay, A comma 50. I'm going to add a value called 50 to all pixels. and I'm going to show it in a subplot of 1 comma 1 rows 2 columns. First image I'm show of A, and subplot of 1 comma 2 comma 2. Okay, I'm show of B. So I'm going to save this as example 4. Okay, so this is the output. The intensity is, I'm going to increase the value to 50. So check before that we can check this one. So if you click A, this is the value of A. It contains of 256 rows and 256 columns, and this is 1 comma 1. If you check B, 206. A value is 156 and B value is 206. It means every pixel, like 50 has been increased, so that the intensity level is increased. So it could also increase to 100. So the maximum level it can go is 255. So if you check the variable A now, A is 156 whereas B is 255. Actually it should be 256, but it can store only the 8-bit information, so it has round off to 255. Okay, this is image addition. The same program you could use it for image subtraction. I am subtract. So run the program. So this is image subtraction. I explain you the program once again. You could read the image by using a command called imread, then imadd or imsubtract. Like other multiplication, other operations, you can also use. You could type help imadd in command window. So this will give you the different type of like operations, mathematical operations on the image, like im complement is there, im divide is there, im subtract is there, im multiply, and im linear combination is there, im multiply is there. Okay, so you could, if you want to add 2 images, that is also possible. So you could read one more image here, b equal to im read of rise.png. This image is also by default it will be stored in the Matlab root folder. So else you have to keep the image in the current folder. So if you check now, so take the image from Matlab default folder. So this is the image. So if you want to view that the image which has been added, so subplot of 1 comma this, make it change as 3 because we have 3 images now. 3. Okay, and this is also 3. So if you check now, like this should be of B and this should be for C, like because we cannot use the same variable. You make this a C, save the program, run the program. Okay, so this is the first image, this is the second image, and this is the image subtracted image. Okay, you could also add add. So this add the image. Add the image. Okay, so you could also type this one because it's a double format. Okay, so if you want linear addition, then you could use help imadd. You could go for a linear combination of images. See, imlincom is a linear combination of images. I'm choosing this image. Right click, evaluate selection. Okay, so this is the linear image of linear combination images. In this program, like first image is rise.png has been read and it has been stored in variable I. Similarly, cameraman.tiff is also read and it is stored in J. And imlincomp is the function which add the linear combination of images I and J with unsigned integer 16 format. So the output will be displayed in im show of k. So this is the linear combination of images. If you want to check im complement, help im complement will give you the complement image. Like, see, if you could choose an example here, right click, go for evaluate selection. So this is the input image, this is the input, and this is the complement image, inverse image. Check here, red, black. All the black will be white here, and all the white will be black. Okay, just an inverse, like so. It's a complement image. So that's all about mathematical operations. So you could type help IMAD, and you will get a lot of functions here. So you can try the other functions like IM complement, IM divide, IM linear combination, and IM subtraction, IM multiply, like that. So if you want to increase the intensity level of the image, you can use IMAD. If you want to go for background subtraction, then IM subtract. You could use the commands like IM subtract. With some other commands you could process, and you could implement background subtraction. Okay. So coming to the color channel separation. Okay, before going to the program, let me explain this program. So in this program, like we are going to split the red plane and green plane and blue plane, which is used for processing, further processing. For example, if you want to go with color image segmentation or color image denoising, then you have to first separate the planes, then you have to process. So in order to separate the planes, like first thing is you need to read the image. A equal to im read of rose.png will read that image, and im split is a command which is used to split RGB. Like red, R will contain the red information, and G will contain the green information, and B will contain the blue information. Okay, and im show is for display, and this colon comma 1 is like these are all the three planes. Since red is the only information and green and blue are the zero information, because if you visualize this as R, if you, for example, if you give IM show of R, you will get only a grayscale kind of image. But if you want to visualize the red component, then you have to make the green and blue component as 0. Okay, so I am loading this red component to the first plane and green and blue component to the, and I'm making it green and blue component to 0. Whereas for green, I am making the first and third plane. That is the first red is the first plane, green is the second plane, and blue is the third plane. So I am making first and third as 0. Okay, so green is loaded into the image, and for blue, like third plane, like only first and second, I am making to 0 to visualize. So I'm going to copy this program. Edit, open the editor window. So I'm going to paste here, right click and paste here. Okay, save as example file. So I'm explaining one more time, like if you check here, like see, if you're going to display only that R information, red. Okay, but when you visualize the image with this option, like you will be getting this image red, and this is green to visualize the green pattern, green channel, and this is to visualize the blue channel. Okay, so I'm explaining the code one more time here. So what happens is, I'm reading an input image. A equal to im read is reading an input image. So if you check here, the planes will be 3 planes. Okay, 387 into 467 into 3. It has 3 planes. Okay, but when I give im split, R will contain only of one plane, 387 into 467, and green will also contain 387 into 467, and blue is contain 387 into 467. If you visualize as R, it will be like a grayscale image. Okay, if you visualize like if you copy this and visualize the G, okay, Control Z, Control Z. Okay, I'm going to copy this one and put it in command window. I'm going to visualize only G, so it is also, it looks like a grayscale image. But if you want to see the red component, then you have to arrange a image such a way like only green, you have to make the green and blue component as 0, and you have to load the red component. So by doing that, you could do blue component. So this color space, this plane separation is used for color image processing. Like, it's a basic thing which is used for color image processing. For other color image applications, it is the first process. It's like a pre-processing step. So coming to edge detection, okay, edge detection. So I'm going to open a new program here. A equal to IM rate of so I'm disconnecting this one. Cameraman.tiff, okay, cameraman.tiff is the, before that I want to clear all the variables which was created in the previous program. Clear, close all the figures, close all. Cameraman.tiff and b equal to edge of a comma canning. Canning is a edge detection technique. So I'm going to view that image subplot of 2 comma 1 first image, okay. This is the input image, so I'm going to give this title as input. Copy this one, control V, okay. This is the second image, third image, this is the fourth image. This B will give you the edge. This is canning, method by canning. So I'm going to add 2 more methods. C and this is D, okay. Canning this as Sobel and this as Privet. So save the program. Example 6. Okay. So now I am going to run the program again. So breakpoint is used to stop the execution as well as you can debug the operations. Like you could, like, if after keeping the breakpoint. After keeping the breakpoint, like you could keep the mouse on the variable and you could check. You could debug the window. That's the advantage of breakpoint. So here we have not changed the C and D. This is scanning as Sobel and this is as Privet. C program. So this edge detection is by Annie and this is by Sobel and this is by Privet. If you want to process for a color image, right, rose.png, so like you got an error, like it won't. In this case you have 2 options. One, you could load only the red component or green or blue component, or else you have to load it separate and you have to combine it separate, or you can go for converting to a grayscale image. Okay, I'm going to convert to a grayscale image, RGB to gray. But when you convert to a grayscale image, definitely there will be loss of information. So this is scanning as by Sobel and this is by Privet. So converting grayscale. So instead of that, if I'm going to use IM split of A and this is R and this G and B, and I'm going to pass A equal to R. Okay. So only the red component. I am passing only the red component here. So in that case, the change edge detection is vary from the previous case. Okay, so this is an example for edge detection. I will explain you the code one more time. So imread is the command which is used to read the image. Imsplit is the command which is used to split red component, green and blue component. I am loading only the red component here. Edge is the command which is used to detect edges based on various methods. So that method you can pass. You could, whatever the command is there, you could type help edge in the command window. You will get the detailed information about the help, and sometimes you also get the sample source code. Okay, so you could make use of the sample source code and you could write your own program. And subplot is for we have 4 images, so 2 rows and 2 columns. So first image, second image, third image and fourth image. And title is input, title is scanning, and title is Sobel, and title is pivot. So far we have covered up reading and storing the image, and DICOM, how to read DICOM images, and example 3 we have caught up like how to convert a color to grayscale and a grayscale to binary. Example 4 we have converted like how to do mathematical operation like image addition, image subtraction, linear combination of images, and I am divide we have not, I am absolute difference, I am complement. So those operations we have gone through. And example 5 like we have like it's how to separate red, green and blue planes, separation of color channels, that we have covered up in example 5. In example 6 like we have covered up like edge detection, basics of edge detection, how to detect edges from images. So that, and the next part is on like noise and filtering. Okay, noise and filtering, how to add noise. So I'm going to clear the variables first save the program. I'm going to save as example 7, clear the program. A equal to imread of cameraman.tiff. Okay, first I read the image, A equal to imread of cameraman.tiff. To add the noise you could use like help im noise. Okay, you can use help im noise, you will get a sample code there. You can copy the sample code and paste it here. Copy the sample code. Salt and pepper noise. Okay, we are going to add a salt and pepper noise of variation 0.12. First I'm going to visualize only the noise. Subplot of 1, 2, 1 I am show of A. Subplot of 1, 1, 2, 2 I am show of J. Okay. So run the program. So this should be A. So if you check the window, this is the input image and this is the added image. Okay, noise added image. So now we are going to apply median filter. C equal to med filter to of J comma, this is the mask 3x3 mask. This is C. I'm sure of C. Okay, so save the program and run the program. So if you check now, like if you check the, okay, this is 3. this is the input image, this is the noise added image, and this is the filtered image. I'll tell you how it works. If you check the variable here, like A, C, and J, okay. So the A contains C input matrix, and J contains the noise added image. Okay, the pixel values which were 0 and 0, these are all noise. Whereas if you check A, there is no noise here. Okay, there is no noise here. Whereas in J, like these are all the noise. Okay, so the B, C contains, like if you check C, these are all the median filtered image. So what happens is it will take 2 cross 2. For 2 cross 2, it will take the median value of this neighboring pixels. 3 cross 3 means like it will 1 comma 1. For example, if you take this one, 156, 159, 158, 157, 158, 159, 156, 160. All this value it will take, and will take the median value for those values, and it will replace this value as with the median value. Similarly, for this value, it will these are the neighboring pixels, the 3 cross 3 mask. So it will take 159, 158, 155, 158, 155, 158, 159, and 154, and take the median value for those pixels, for those values, and it will replace that value. So by replacing that, the noise will be reduced. So because it's like salt and pepper noise is like by taking the median value, you could see if you check the noisy pixels here. So these are the noisy pixels, 0, 0, and 0, 0. These are the noise pixels. Okay, this noise will be eradicated by doing this median filter. Okay. So I'm going to add a Gaussian noise now. Help IM noise. So different noise need different filters. Like one filter cannot work for all type of noises. So you have to choose the correct filter for the noise. So I'm going to apply Gaussian noise, and this is Wiener filter. Wiener filter equation is there. On substituting this equation, like you will get for finding the neighboring pixels. Okay, so the noise will be removed. So once I run the program, this should be K. Run the program. So if you check now, like this is the Gaussian noise, and this is noise. Okay, filtered image. So I will explain the program once. You read an input image, apply IM noise, type is Gaussian, and these are all the noise variants. You could change to increase the noise as well as to decrease the noise level. And this is the mask. Wiener 2 is the filter, and 5 cross 5 is the mask. It's a neighboring pixel value. It could be 3 cross 3 or 5 cross 5. And K is output. So, and we are plotting that in subplot. So A will have the input image, and J will have the Gaussian noise, and K will have the Wiener filter. So noise and filtering. So with this we have come to an end. Initially, like we have planned a lot of examples on this image processing using Matlab, since most of the commands are like due to speed, like to reduce the speed, they're not able to cope up with the speed. So we have added those examples in learn.pantechsolutions.net. So that's only for the pro version. We will be adding nearly around 5 to 6 experiments there, like counting the number of objects, and thresholding and segmentation, and few more applications like morphological operations, IM erosion and IM dilation. Those examples will be there in learn.pantech solutions, which will be updated today or tomorrow. And so this like day to day, like we'll go through the feedback today and we will improve the next version of the video tomorrow. So your feedback is more important. So like practice is more important than like so we have planned to keep up this videos in channel, so you could review this video and you could practice on your own. And for the pro version, like we have a separate comment box there where you will have a dedicated support. Like if you found any problems in execution or screenshots, you could take the screenshot, you could upload in the comment box there, so our team will reply you. So with this, I will thank you once again, and I will close this session, and let us